Okay, get a shout out. Like, comment, and subscribe Brian's channel. All right, going over the answers here. Some sample answers. You do not need the operator this here because there's no confusion over what the instance variable is versus what the parameter is. Okay, so you could technically leave the default constructor blank, and it would make the age 0, which is fine. I didn't say what specifically to set it to. I don't think that's anything wrong with that. My issue is if you leave this default constructor blank, what's it going to set the name to? Null. And my issue with having a name as null is if in your code somewhere you accidentally try to length it, or substring it, or index of it, and it's null, what error are you going to get? Null pointer exception, exactly. So I would like you to at least, for strings or any other objects, at least set them to an empty string, or at least call a default constructor if it's a different object. Do something so it's not null. Derek, you just remind me which one you had a question on. Let me know. The second one, again, you do not need the this operator, but you could put it in there, especially if you made the parameters the same name as the instance variables. In this case, it's not needed. These parameters can be named whatever the heck you want. They don't have to be the name and the age. They could be N and A, but they do have to be string and int there. One of the common mistakes is not having the instance variable on the left and instead having it on the right side of the equal sign. Make sure name and age are on the left side of the equal sign, so you're actually assigning values to the instance variables and not the parameters. Questions on either of those? I did see a couple people write super for 1 and 2. Person's not extending anything except for object. There's no reason really to call objects constructors, so shouldn't be any super here. Now, there will be a little supering going on because then we're talking about an employee, which extends person. So now an employee is a person. The first one, default constructor. All right, what would happen if I didn't have super in this default constructor? Java put it in for me anyway. So if you accidentally left off super on the default constructor, guess what? It's your lucky day, and Java's going to save your life and implicitly call the default constructor for super. What you should not have for sure inside of employee is any talk about the name or the age. Why? Because they're private in the superclass. You cannot see the name or the age or assign any value to it here, so you call the super constructor. Questions on that one? Yes, Rachel. You do not need this. No. I did not make this answer key in all honesty, and I think they were just trying to hit you hard with the thises, but you don't need any thises there. Now, if you don't put this, Java's going to automatically append it for you. So it's not wrong either. It's just probably redundant, unnecessary. Extraneous, is that the word I'm looking for? Number 4, add a 1 parameter constructor. So I've got the name there. I'm sending that up to the superclass's 1 parameter constructor. I know what you're thinking, well, that's not going to do anything for the age. Well, yeah, the superclass's 1 parameter constructor, I guess, doesn't do anything for the age, so it sets it to 0. I don't know. That makes the department unassigned, ID equals -1, and again, this is not necessary here. You could have chosen a different value for the ID, a different value for the department. That's really not what's important here. The biggest important thing is you call the superclass constructor, send it the name, and then also you initialize the department and ID to something. Does this variable name have to match this variable name? No. Really all that matters is that this takes in a string and you send it some string. You could call this N, you could call it whatever you want to, but the idea is this has to be a string. number 5, I think it says 3 parameters there, or 3 arguments, so that's why you don't see anything about the ID there as a parameter. Now in this case, if you do name the department parameter department, you do need this to clear it up. But maybe, what did it say in the video? Suppose you're smart enough to not name your instance variables the same as your parameters. Maybe you were smarter than the average bear, and you didn't do that. And again, the name and the age, those parameter names, they can be whatever as long as one of them's a string, one of them's an int. You can name whatever the heck they want. It's just a coincidence that those parameters are the same names as the one in the superclasses constructor. There's other options for number 6 that you could do as well. Just saying, what other constructors could you make? Derek, you had a question. Did I answer it? No.
So, is it possible to call it one object constructor with the same object?
Yes. So, as an example, for the default constructor here, let's pretend that you've written this constructor first down here that's supposed to take in a name and an age. My default constructor could do something like this instead. Literally like this. If I don't put all this stuff here, if I say this, unknown and 18, it replaces this with the name of the class, which is person, and it will actually call this constructor and send an unknown for the name and 18 for the age. And so it'll use the specified constructor basically in the default constructor. Is that kind of what you're asking, or?
Let's say like a constructor that can take it up to like 5 parameters. So you like a constructor, and then you have like another constructor with 2. You use that.
Ah, I see what you're saying. Yeah, you could do that too. So, for example, For example, hold on. Yes, you can, Derek. It's just taking me a second. There's not a good example here, but yeah, yes, you can. You would just say this and send it whatever parameters it's needing, and then if there's something else that wasn't added on, you can then tack it on in that constructor as well. So if you want to call a constructor from a constructor, you just say this and any parameters that are required. Is that common? Not really, but you can do it, and it's totally legal. And some businesses want you to do it, depending on their style guide. But you can do it, to answer your question, by just saying this. Okay. It looked pretty good while I was walking around. If you made some mistakes, my hope is that you corrected them and you understand them, and maybe you ask questions about them. Or if you didn't ask questions, you know, have an understanding of what mistake you made, and you've got a correct answer on your paper. Is that true? Okay, cool. I would like you to get out your Cornell notes from yesterday, because we wrote down stuff in it, but we didn't have any good questions. We didn't really have a summary, so I kind of wanted to wrap up yesterday before we move on. Put a wrap on things before we move on here. That's a wrap. All right, so yesterday, I'm sorry that mine are blank. I had to erase everything like I have to with Cami, but yesterday we took notes on Inheritance Day 1, Inheritance and Constructors, I should say. If you are short on Cornell note sheet, maybe you lost yours or your dog ate it or something, or maybe you were just absent, I did put extras out here if you need one. So those are there, but I'm hoping we can just use the one we had yesterday for sake of continuity and organization and saving the planet, whatever. So I wanted to put a question in here first. Give me an example of a hierarchy. What could we do? King and prince. A prince is a prince a king. So all of those are people. So maybe we could have a class person, and then we could have class like court extends person. Is that what those people are called? They're part of the court.
Oh yeah, like the royal.
So they have. So we could do something like that. That's a good idea. Like royalty status or something. Yeah, chance.
Well, like fish, like sharks.
Fish and sharks. A shark is a fish. I like that. And then they could be like a type of shark or something.
Well, like, yeah.
Okay, I like that. Anything else? We did food in the other hour. And it's like 4th hour, about to eat lunch. No. Okay. Okay, let's do, how about we do the, we can do
Do a workplace.
workplace.
Boss.
I like the first idea you have with the person and the royalty. We can do that.
I like the fish.
Oh, you like the fish? Fish? Okay. Okay. Julius is on team fish, so let's do public class fish. Now, let's think. What instance variables would a fish have? Maybe the,
Can't bite.
like,
Teeth.
teeth. How do you represent, like, number of teeth?
Boolean teeth.
Boolean teeth.
Eats other fish.
Boolean tooth is a cannibal. Fins. Okay, how about this? Private int num fins.
Oh yeah.
Okay, weight sounds good. Maybe weight would be a double. Oh my gosh, that's a good idea. Is salt is fresh or whatever?
Or, well, if it isn't salt, you know it's trash.
If it's both, then it's got golden blood. I think maybe let's just leave it with fins and weight. I'm just thinking I don't want you guys to have to write too much here. So let's just leave it with num fins and weight, and let's say something. Let's make a constructor for fish. Public fish. And it's going to take an int for the number of fins, and it's going to take in a double for the weight. Double W. And the constructor will just be, you know, num fins equals f. This is kind of what you want to be, NF. This is what you want to be doing when you're coming up with these questions over here. Just come up with your own questions. Make an experiment in your head. Say, I wonder what would happen if blah, blah, blah. And use your creativity. I think we've said it before, you guys have more creativity in your pinky finger than I have in my whole body. So come up with something creative like this, a fish and a shark. Now, a shark is a fish, correct? Okay, so let's kind of do a partial declaration of the shark class. If I want to indicate that a shark is a fish, I'm going to say what? Extends fish. Very good. Oh, sharks are so cool. Like you never outgrow sharks being cool. They can be cool when you're 2, they can be cool when you're 99. Say what? Not going to be part of the shark fan club at that point. Shark attacks. Didn't somebody in CS1 do shark attacks for their final project data? Yeah, are shark attacks very common? Okay. So you can. I was reading. I think I was telling you guys maybe my wife and I are going to Glacier National Park over the summer, and it's grizzly bear country, and I'm terrified of grizzlies. And I was reading though that you have a higher chance of getting in a car accident than being maimed by a grizzly. Then again, I've been in a car accident in my life, so I'm thinking, does that mean I'm going to get maimed? All right. I know that's not how probability works. Please don't tell Miss Beasley on me. Let's just keep going here. All right, now, and there's like 2,000 people every year that are left-handed that die from using right-handed products. Can you imagine just trying to use scissors and just, okay. I know, being left-handed, geez, I know. All right, let's bring it back in here for a second. How is a shark going to specialize a fish? What extra instance variable? Oh, teeth. Champas. Like how many teeth? Don't sharks have like a bunch of teeth? All right. Let's do like private int num teeth or something. Sharks are cool. And then when they lose a tooth, they have like 17 that come in behind it. It's like a hydra. It's insane. All right. Sorry, I didn't mean to say that. Okay, here we go. Public. Let's write the constructor here. Public shark. And let's say we're trying to specialize all that stuff. So the number of fins, maybe I'll say int fins, the double for the weight, and then int num teeth or something. NT, how about that? Sorry, I know it's kind of overflowing onto the notes there. So sorry. You can make it work. Whew. So my question would be, I guess, write a constructor. So if you were actually coming up with a question, I probably would have cut it off right here and said write the constructor for shark. So what do I need to include? Super. Now, let's think about this. That's obviously not what I want, first of all, because I have variables for the number of fins and the weight. I'm not doing anything with them, so I obviously don't want to call it the default constructor. But this is actually illegal. Does anybody know why? Ben, you got an idea? No. Yes, no. Yeah. Exactly right. There's no constructor with no parameters in the fish class. Now, yesterday we said a default constructor will be created for you when there's no other constructors. Since we've created a fish constructor in the superclass, that means Java will not create a default constructor for us. So this is actually illegal to just try to call a default constructor. So no, not what I want. What do I want here? Well, I want to send the variables that represent anything in the fish class to fish's constructor. Which one of these variables represent? Well, fins represents the number of fins. Now notice here, fins and NF are different names. Is that okay? Absolutely. They represent the same thing. They're both integers. We're okay there. Then I also need a W for the weight. I made it called WT. Is it okay that weight and W and WT have different names? Absolutely. Then I want to go ahead and specify the number of teeth. So I'd say num teeth equals NT. Oh, excuse me. Mufasa, push the feeling. Is this okay? Did you guys want to write a line of code where we actually create a shark? Would that be helpful? Or do we just get we got the hang of it? Okay, we're good? Okay. So what I would do, like when you're testing yourself, coming up with questions for yourself, I would have stopped right here, and I would have said, write a constructor for shark. Okay, well, do that. You can come up with all kinds of mental experiments. This is just one mental experiment we came up using your creativity. Thank you for your creativity. All of you that came up with suggestions or were thinking of suggestions there, I appreciate it. Now, any questions? Before we move on, down at the bottom there's a summary section. So I thought maybe we could come up, here's how I want you to do a summary. Pretend your friend was absent yesterday, and you just passed them in class, and he goes, hey, what did we do in computer science yesterday? And you got to give them like a 4-sentence rundown, summing everything up.
It's like a POV.
What is it?
It's like a POV kind of thing.
Yeah, POV thing, sure. So, pulling out what we talked about yesterday, maybe looking at your notes. I want at least 4 important things. Can anybody give me one important thing about what we did yesterday? Julius, go ahead.
So classes cannot access the private instance variables.
That beautiful. Subclasses cannot directly access private instance variables. Julius, you said that so well. Instance variables. Subclasses cannot directly access private instance variables of the superclass. Wow. That's got like all the vocab. It's got truth, which is important. And that's an important statement. Yes, we cannot directly access any of the I think that's a great place to start. Because before you even talk about using super, you have to go, why? What's the point? Britton, you got something.
Constructors and the subclass aren't inherited from the superclass.
So subclass constructors are not inherited by superclass constructors? That's true. And vice versa. Well, constructors are not technically, subclass constructors are not inherited by the superclass, so you can't create a employee from the person class or vice versa. What else? You just put on your sweatshirt? You didn't want to give me one? So, like, what is super? Why do we use it? So you're gonna not tell your friend about super? Some friend you are.
Well, they didn't watch the YouTube video. Yes.
Hey, you just go, hey, watch the YouTube video. You know, can I tell you something about the YouTube videos?
Yeah, we know you're monetized.
Yeah, we know you're monetized. Oh my god.
65 views, 2.5 hours. Let's do the math on that. Not bad. All right, 65 hours. No, 60. No. 2.5 times 60. That's the number of minutes that have been viewed, divided by 65 viewers. So I'm getting an average of 2. I think my viewer engagement level is pretty low here. 2.3 minutes per view. Maybe you guys are very efficient. Maybe you guys just put it on like speed. You put on double speed. Yeah, Eileen.
Actually, you're assuming that all people watch the same amount, but I will tell you last week I watched 1 hour of one.
Oh!
So that's even less than
No, so really it's like, so 64 people watching an hour and a half. Now I will say also I'm complaining when look at my view time went up by 999%. We're taking it to the streets, people. We're going viral. All right. Where was I? Courtney, did you want to add something important?
Yeah, when you bring it back to what it first.
Thank you. Super must be the first line. Super must be the first line. In a subclass constructor. Now, you probably wouldn't get into telling your friend in the 30 seconds you see him in the hall that if you forget to put super, that Java's going to automatically call super with the default constructor call first. But maybe if you have a little bit more time with them, you'd add that in. So, can somebody tell me what super is? Which constructor? Eileen, do you want to give me a rundown?
Sure. So when you have your subclasses, you use super in order to initialize all of the instance variables that's inheriting.
I wish I could say it better myself, but I'm incapable, so I'm going to totally butcher this here, okay? Super is used to initialize the inherited instance variables. It's basically a call to the superclasses constructor. Let's see, here's what third hour said. The third hour said the first line of subclass constructor must be super. We got that. Constructors of the superclass can be called using super. We kind of have that. Subclass must extend superclass. That's true, but that's not part of the lesson yesterday. Instance variables from superclass are inherited but are not accessible because they're private. I think we got it all. I think we did a good job. Anything else you guys want to? Anything else you guys want to add? Okay, your friend's good. Your friend's good. Yeah, it's just an acquaintance. It's just an acquaintance. You're not tutoring them. Okay. Cool. We are going to move on today to something called overriding. If you could click on this 9.3, and I figured you guys could just flip over your Cornell note sheet to talk about overriding. If you don't have room, though, I do have extra Cornell note sheets over there, or however you want to do it. But click on this. while you're doing that, here's something to think about. Suppose we are designing a superclass vehicle that will have many subclasses, such as car is a vehicle, truck, train, airplane, boat. Truck is a vehicle, train is a vehicle, airplane is a vehicle, boat's a vehicle. Some of these subclasses may also have subclasses such as truck. So a pickup is a truck, is a vehicle. A flatbed is a truck, is a vehicle. A long haul is a truck, is a vehicle. We want each of these classes to have a method that will return the unique warning sound associated with each vehicle. What sound does a car make? Honk honk. What does a airplane make? Like 120 decibels. What does a train do? Have you guys seen a train before? I thought it was like choo choo. No? Okay. What about a truck? Well, it depends on the. Oh, if it's a long haul truck, it's probably like. If it's a flatbed, maybe it makes that sound when it backs up. Beep, 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 beep. And if it's a pickup truck, it's probably just honk honk, right?
Be like a press.
Okay. All right. So, how could we design for inheritance to provide this functionality? Is that a train?
Train, yeah. But train is yeah, that's a train.
That's a train if I've ever heard one.
It's a steam whistle.
It's like the ones that are never moving around over by the train tracks on, what is that, Industrial over there, that are just parked on the train tracks? Alright. Alright, so here's how you could do this. Vehicle could have a warning sound method that returns a string that represents what they sound like. Honk honk, choo choo, whatever. But then each subclass could have its own warning sound method that will return the warning sound appropriate for that class. So check this. Here's the whole point. Let me go back to this inheritance relationship. What we could do, if we put inside a vehicle, we put in public string warning sound. I know there's a capital O there, so sorry. We're guaranteed that all vehicles are going to have a warning sound, because I put it in vehicle, and that means any subclasses of vehicle are going to inherit it. Does that make sense so far? So for a vehicle, it might just be very basic. We could just say return or something. But then each one of these could have their own warning sound method. What this means is I could have a vehicle array, something like this, that contains a new car, a new truck, a new plane, airplane, okay, airplane, a new train, whatever, train, something. Okay, what method am I guaranteed every single vehicle is going to have? Two string, yeah, they're all going to have two strings, but since vehicle has a warning sound, all of these are going to have a warning sound. But they could make their warning sound a little bit different. What I'm trying to say is, we could then have some enhanced for loop, and inside of it we could do something like this. And it would go honk honk, whatever, honk honk, and choo choo, because they all have their own warning sound. We're guaranteed that a vehicle is going to have a warning sound because any subclass of vehicle inherits that warning sound. But you could also specialize that warning sound method. This whole idea I'm talking about is called inheritance, and it is mentioned on that link. So I'm going to click on it, and we're going to write some stuff down here. Okay. Overriding methods. I'm going to start my second page of notes with that up at the top. I'm going to say overriding methods. And this is, if you really want to know, it's 9.3 on the CS Awesome site. And today is 2/7/2020. Okay. So, reading from the site here, you can read along with me. It says a subclass inherits all public methods from its superclass, and these methods remain public in the subclass. So, for example, warning sound would get inherited by any subclass of vehicle, whether it's car or truck or even long-haul truck. But we also usually add more methods or instance variables to the subclass. Sometimes we want to modify an existing inherited method. For example, I don't want an airplane to say honk. This is called overriding methods. I don't recognize. Mr. Foster. I do. I can send her down. Okay, it's like by the library. Okay, sounds good. Yep. Bye. Courtney, that was for you, library. I don't know. Just go to library main desk. Somebody. I don't know. Hopefully I'm not sending you to your doom. Okay. Sometimes we want to modify existing inherited methods. This is called overriding methods. Overriding an inherited method means providing a public method in a subclass with the same method signature, that's the first line of a method, as a public method in the superclass. The method in the subclass will be called instead of the method in the superclass. One common method that is overridden is the two-string method. So for example, do you remember what happened when we were first making classes and objects? We made an object and we tried to print it out. What did we get? We got like vehicle at 12B47F3D or something like that. Because that's the two-string we inherit from object. And then I said, write your own two-string method. And then when you wrote your own two-string method, it looked very much nicer, right? That's the same idea with overriding any method. You can take a method that you're inheriting and write your own version of it. So what I'm going to write down for my definition of overriding is the following. Overriding. Let's see. For overriding, I'm going to say providing a method in a subclass that has the same method signature which is that's just the first line of the method. You know, the one that has public, the return type, the method name, the parameters. So providing a method in a subclass that has the same method signature as a method in the superclass. And what was also added was that this method in the subclass will be called instead of the method in the superclass. I should have written that in red. I'll highlight it here. So as an example, using two-string, if you don't write your own two-string method, you inherit one from object. Everybody inherits one from object. The one in object says what type you are, the @ symbol, and then a bunch of weird gobbledygook numbers and letters. If you write your own two-string method, then you can say this is a rectangle with length blah blah and width whatever. You can say this is a circle with a radius whatever. This is a person whose name is da 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 and they're age 27, whatever. But if you don't override it, you're going to use the one that you inherited. Just like, do any of you have a parent with a bad sense of humor? Probably your dad. Okay. So you can, instead of using their sense of humor, you could override it with your own sense of humor. Something like that as another example. So I'm going to write down an example as two-string. We're going to do our own example in just a second here. So you want to write your own two-string method so that you don't use the one that you inherit from object. So let's look at this example here. It says in the following example, the mean greeter inherits the greet method from greeter, but then overrides it. Run the program to see. So let's see here. There's a class greeter that has a method called greet, and it says hi. We go ahead and we make a greeter, and it says g1.greet, so he's going to say hi. Then we make another greeter, but he's a mean greeter. And if you scroll down and look at the mean greeter class, he has, this class has overridden public string greet. If you look at both of them, public string greet, I don't know why my screen turned off, public string greet up here, and then public string greet down here. Since a mean greeter is a greeter, then mean greeter would use the greet method that's been inherited. However, since you're overriding it in mean greeter, the greet method for a mean greeter is going to say go away. So if you go ahead and run it, you'll see that the regular old greeter, this first one, G1, says hi. The second one that's a mean greeter uses the overridden greet method and says go away. Can you imagine if you walked into Walmart, it's one of those nice old people greeting you and they just tell you to get the heck out of there? How rude. I will not be buying any Clear American sparkling water today, sir. You've lost a customer. It says we should write another one. It says, oh God, add another subclass called Spanish greeter that extends greeter and have it say hola. Okay, let's do it. Let's write another class. Spanish greeter that extends greeter. Alright, I want to leave it right there for a second. Before we go ahead and we override the greet method, I want to leave it right there for a second. If a Spanish greeter is a greeter, it's going to inherit any private instance variables. It's also going to inherit any public methods. What is Spanish greeter going to inherit from greeter? Greet. And so right now a Spanish greeter is going to say hi. If you don't believe me, on line 12, go ahead and change the mean greeter to a Spanish greeter. And then when you run it, you should see that the Spanish greeter just says hi. Why? Because it's using the method that it inherited from greeter. I've had to say greet like 100 times today, and it's a very strange word, and I just feel like I'm going through circles. So come pour water on my head if things start going wrong. But it says we want to write our own. We want to override the Spanish greeter method. The greet method. So I'm going to take this greet method here. I'm going to copy it and paste it into Spanish greeter, but instead of it saying hi, I'm going to have it say hola. And so now when I run it, the Spanish greeter says hola. Because it's going to use that overridden method. It's going to use the overridden method. I overrode greet and made it do whatever I wanted to. You could have other ones. You could have Japanese greeter. How does what is the greeting in Japanese? Konnichiwa. Oh yeah, you know because you lived in Japan, right? Yeah. I want to make sure that the microphone picked that up. That you live. Okay. I wouldn't just want to say to somebody, "Oh, you know." Obviously, you know because you lived in Japan. Okay, gotcha. Any other language greetings? Yeah, Rachel. Oh, aloha means hello and goodbye. I like it.
You could go like, sup little baby.
Sup little baby. It could be like what would that greeter be? What would that greeter be? Cool greeter? Fresh greeter? Dope greeter? Dope greeter would say sup little baby. All right, so you could. Julius, that is a good callback. Thank you. I appreciate it. So you can make whatever type of greeter you want. Basically, you're overriding the greet method so that it can say whatever the heck you want it to say. Same thing with any other method. If you inherit a method, if you inherit your sense of humor from your parent, you can override it with your own. Okay? Are there any other examples? No. I think this is a good time to take our 2-minute. Let's go ahead and stretch our legs, get a drink of water, stuff like that. It's about 12:25. Let's try to be back by 12:27. And then, all right, let's get back to it here, people. So before we do any overriding, there's one thing that people get really, really confused about, because there's also something called overloading when you're talking about methods. I just want to make sure we get both of them straight before we actually do something. I've got a nice processing activity ready to rock for you, but it says down here, don't get overriding a method confused with overloading a method. It's very common. They're very different. Overloading a method is when several methods have the same name, but the parameter types, order, or number are different. So with overriding, the method signatures look identical, but they are in different classes. In overloading, the method names are identical, and they have different parameters, and yes, they're in the same class typically. So my best example of overloading is substring. We've talked about the substring method. Substring has a one parameter method where you just send in one number. Does anybody remember what that one does? Substring, if I just say substring 2. Starts at 2, goes to the end. There's also a substring method that takes 2 parameters. Substring is an overloaded method. Same exact method signature, except different parameters, and it might behave differently. Another example is default versus specified constructors. A default constructor takes no parameters. A specified constructor has the same name, public person, but then it takes in some parameters. Those are overloaded methods as well. People get them confused because they start with over, and they deal with methods, but they're completely different. So I'm just going to write that down before we do our activity here, just so I don't get confused, and I don't want you to be a victim of confusion either. So overloading is when two methods, really it's 2 or more methods, have the same name and return type, but different parameter list. And when I say different parameter list, it could be different types, different amounts, all that stuff. And it's also in the same class. In same class. So my 2 examples are the substring method. For example, you could do str.substring with a single parameter, or you could do str.substring with 2 parameters. That is an example of method overloading. They're both substring, they both return a string, but the one on the left takes a single parameter, the one on the right takes 2 parameters. My other example is constructors. So for a constructor, you might have a default constructor, something like new person with no parameters. That would be a default constructor. And then you might also have new person that takes in a name or something like that, Billy. So those are examples of overloaded methods. They are the same method. They both are constructors, but they have different parameters. Substring, same method, returns a string, it's named substring, but different parameters. So we're not going to do overloading today, but people get those confused. And since we're going to be talking about overriding a lot, I don't want you to think of overloading. So I just wanted to define it there for you. And they've got a couple examples, but whatever. I want to do some stuff in processing. You guys ready? Okay. My body's ready. All right. You need to follow some very specific instructions. If you goof it up, it's not going to work. So here's what I need you to do. First of all, open processing. So I think the best way to do that for me is if I hit the Windows key. What? You lost my screen. It's not your fault. Anybody else lose my screen? Okay. So the first thing you need to do is open up processing. I think the easiest way to do it is hit the Windows key and just type processing. And then usually it pops up eventually. It's got that I to the 3rd power logo. Courtney's not back. The guy on the phone said just put on blindfold and be okay. So I think everything will be alright. Alright. So now I've got processing open. Now there's 2 files. I need you to be very careful about which ones you do and where. So on the classroom, I want you to do the first one that says ball runner. That is the first one you need to click on. There's 21 lines of code, I believe. Just copy those 21 lines. Copy it. And paste that directly into processing. Now, it's not going to know what ball is yet because we don't have any definition of ball. But let me tell you what this does right now. What it will do is make an array of ball objects called balls. And then inside of setup, it'll size the window to 640 by 480. It'll make an array of 10 ball objects. And then there's this method that initializes them called init balls. Right now, I just made them all type ball. Then inside of draw, I basically said set the background to white. Go through every single ball in balls and display it, move it, and bounce it. Now, there's no ball class built into processing, so guess what? I've got one made for you. If you look at the second link that says ball class, you need to go ahead and copy that code, and you're going to put it in a very particular place. It's 55 lines. Copy it. Then in processing, I need you to do the following. You'll hit this down arrow up here. And then you're going to hit new tab. So this down arrow, new tab, and you're going to type in ball with a capital B. Hit OK, and then paste the ball class in there. Now you should be able to run it and see balls bouncing around the screen. I need to walk around and make sure it's working before we go any further. Go ahead and run it if you got everything in there. Good. Balls. Good. Balls. 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 Is the other tab major? No, it's fine. That's two different tabs, but this one should be the all one. Oh yeah, just go ahead and paste it in there. Try that. Does that work? What is this? What did I just step on?
What is that?
What are those? Good. Okay. Got it, balls? Balls, okay. Julie, did it work?
It looks like
Okay. Alright. Okay. So we got, okay. Well, so let me explain really quick. The ball class, you guys aren't super familiar with it, so let me explain really quick before we do stuff to it. So every ball has a diameter. That's how wide and high it is. I made just a diameter instead of a different width and height, so they're all circles, basically. I gave it a color. I spelled it, unfortunately, the British spell. Okay. I gave it an X and Y that keeps track of the position on the screen, and then I gave it an X velocity and a Y velocity so it can do the bouncing and switch those velocities. The constructor just goes ahead, it puts every ball in the middle of the screen to start, and then randomizes its diameter, X velocity, Y velocity, and color. I've got to just, now, okay, these are the 3 methods I want you to pay close attention to. There's one method called display that draws the ball on the screen at a specific spot. It makes the fill color whatever its color is and draws the ellipse on the screen. There's a method called move that just updates the X velocity and the Y velocity. And then there's a method called bounce. And all bounce does is, well, you could look at it. I'm not going to get too far into it, but essentially checks if the right edge hits the right wall, switch the X velocity. If the left edge hits the left wall, switch the X velocity. If the bottom edge hits the bottom wall, switch the Y velocity. If the top edge hits the top wall, switch the Y velocity. That's what it all does, so they bounce around. And sometimes you'll get one that has a random no velocity. Sometimes you'll get other ones. But it should be different every time. Now, what I wanted to do was make some different types of balls. So I made 2 different balls, one called big ball and one called flashing ball. See if you can figure out which one's which.
That's big ball.
No clue.
I think it's big ball. It could be flashing.
Which one do you guys think is mine?
All right, let me run it again so maybe we can see where flashing ball. Yeah, you gotta see flashing ball before big ball inherits the earth.
How come those balls are in front of the big ball but not the flashing ball?
I think it's because of the order that I did it in. If I switch these here, and then I did flashing ball second, that's a good idea. I should do that so you guys can actually see my boy flashing ball, or my person flashing ball.
Whoa, moving now.
Yes, sir.
Oh, flashing ball got that.
Yeah, I
Change
like
it that way.
flashing ball.
Wait, did you say flashing ball got that drip?
Yeah, he drifted.
All right. All right. Now, is a flashing ball a ball? Yes. Which method do you think I changed for a flashing ball? Do you think I changed the way it moved, the way it bounced, or the way it displayed? Displayed. For big ball, which method do you think I changed? Move, display, or... I actually can't remember which one I changed. But I overrode those methods, and I thought we could do one together here. We could override one. Why don't we start with, let's just make flashing ball together. So what I'd like you to do, let me go back to our code. I want you to hit this down arrow again, do a new tab, and let's do flashing ball. Now, I want to say that a flashing ball is a ball. So, how do I say that? Yeah, flashing. Now, in processing, we don't put, I don't think you put public. I don't know. Processing's kind of weird. I just don't. So I say something like that to indicate that flashing ball is a ball. Now, keep in mind, flashing ball is going to inherit all of the instance variables. So a flashing ball is going to have a diameter, an x, a y, a color, and an x velocity and a y velocity. It's also going to inherit any public methods, and there are a lot of them. I put in accessors for everything. I put in mutators for everything inside a ball. Yeah, I took care of all of it, baby. It's all ready to go. But what I want you to think about is display, move, and bounce. Which one of these do we want to override, change the way it behaves for a flashing ball? Display. So if you really want to, here's what you could do. You can just copy the display method from ball and paste it into flashing ball. Now, what I think I want to do is before I do the filling, I need to change the flashing ball's color. Because right now in the regular display method, the flashing ball's color doesn't change. How am I going to change the color? I can't just say color equals something. Why? Because it's private in the superclass. Let's see, is there a set color method? Not in this class, but we inherit from ball. Ball does have a set color method. So what I'm going to do is do something like this. How about color C equals... I always get this messed up. I think you have to say color again, and then you can just make random... So, okay, so in ball, I spelled color with the OU because OR is taken. So they told me to do a British spelling. I know. It wasn't my doing, Derek. I'm sorry. I know. I thought we decided this several hundred years ago. I know. Okay. So I just do that 3 times to make a random red, a random green, a random blue from 0 to 255. Make sure you got all your parentheses right. Now that I've made that color C, I need to change the color to that one. So I'm going to say set color is C. Where does set color come from? I've inherited set color. I can't just say color equals C because color is private. If you were to try to do it, you don't believe me. Why not? I know what I'm talking about. If you were to do something like color equals C, It's going to say color is not visible because it's private in the ball class. So I have to instead say set color C. Next, I got to figure out what to change the fill color to. I could just say C, or what if I wanted to figure out what the color is currently for the ball? I can't just say color, but I could do get color. Why can't I access color? Because it's private in the superclass. But I do have the accessor method that I inherit, so I can see what the color currently is. And now it's saying it doesn't know what X and Y in diameter are. Why? Because they're private in the parent class, in the superclass. So what do I change these to? My accessors. So get X, get Y, get diameter, get diameter. I know, it's a lot. But the reason we have to do that is because X, Y, diameter, color, those are private in the superclass, so I can't access them from outside of ball, but luckily I inherit some accessors. Another good reason to write accessors. Now, do we have this for the most part? Okay. If you don't see any red, you're in a good spot. Inside of this very first sketch file, we actually have to make a flashing ball. What I'd like you to do is just say maybe balls sub 0 equals new flashing ball. I know what you're saying. Mr. Foster, we didn't write a constructor. Okay, you're right. So what's it going to do? It's going to make a default constructor. You know what it's going to fill in for the first line of that default constructor?
Whoa.
I call the super. So now we should be able to see at least one flashing ball on the screen.
Heck yeah.
And if you really wanted to go ham, you could make all of them flashing balls by changing that. You know, you could do something like this. You could make this flashing ball. And so now they're all flashing balls instead of just the 0th one being a flashing ball. If you really want to go wild, you could make 1,000 balls on the screen or something like that if you wanted to. It slows down considerably. Alright, I've done too much here. Let me go back a step. Okay. I think I like it with one flashing ball. One flashing ball is more than enough for me. I'm a simple man. That's all I need. Alright. What I would like, first of all, questions on what's going on. What I would like to do is on Monday make some other different types of balls. So I want to brainstorm with you. What other types of balls could we have other than flashing ball? Ideas. Julius.
Ball that bounces off of other balls.
Okay, I'm going to call it bouncy ball. Bouncy ball, and it bounces off of other balls. That might be tough, but we could maybe make it work. Bounces off other balls. I love it. Off other balls. All right, what else? I know what time. We've got 5 minutes, but you guys can be creative for 5 minutes. Hey, Steffi, could you let Courtney in?
Alright, a ball
Yes, Julius.
that eats other balls, like a Gario.
Oh, okay. And does it like absorb its diameter?
Yeah.
Ooh, so I'll call it a Gario ball. If I spelled it wrong, I couldn't care less. It like I'll know what this means. Eats other balls. What else? Rachel. A ball that gets smaller. So how about shrinking ball? Shrink ball. It gets smaller. Does it go all the way down to 0?
Heck yeah.
Once it's down to
Susie.
0, it starts to shake.
Say it again.
I don't like saying that.
Wait, say okay.
A ball that makes another ball.
A ball that makes another ball reproduce. Copy ball. It makes copies of other balls. Vanessa. A ball that what? Oh, a shaky ball. Shaky ball. Does shaky have an E? Caesar ball. What? Yeah, rhythm. Stick ball.
Like it sticks all the balls to it and makes it go with like the velocity that it goes.
Oh, sticky ball. So it sticks to other balls. Sticks to other other balls stick to it, or whatever. Kind of like that game. What's that game where you're rolling and you keep absorbing like stuff on the ground?
Rolling a snowman?
No. There's a game. Rachel, you got an idea?
A ball that like draws lines from where it's going.
Oh, okay. Derek, stop messing with that computer, please, and fix it back to what it was. So like, how about line ball? It shows you where it's going. It shows its like velocity, magnitude, all that stuff. Oh wait, line ball shows where it's going and where it's been.
No, it shows you where it's been. It shows you
Oh, where it's been. Oh, like it leaves a trail or something. Oh, okay. Eileen.
You have a ball where like they switch colors as they touch.
Oh, okay. How about switchy ball? Switchy ball. Could it also change colors if it hits a wall? Or no? Changes colors with collision. Now, I will say, guys, the collision stuff is cool. It's a little tricky to do collisions. Can we think of anything just an independent ball could do by itself?
Oh, flashing.
Spin, but it's a circle. Oh, orbit. Okay, I was like, a spinning ball. Okay, orbit ball. So a ball that orbits another ball, or like it goes around a fixed point.
Yeah.
Okay, orbits a fixed point. What do you mean it explodes? Like it gets really big and then it's just, and then it's just that cherry or whatever that is. Yeah, rhythm.
So it's like starts with a big ball and then it poops like smaller balls out and the ball becomes smaller.
And I'm scared, but what do you want to call it?
Poop ball.
Poop ball. There it is. I saw it coming. Everybody loves a good poop ball. Poop ball. It poops other balls. Now, does it get smaller when it poops them out?
It gets smaller and then once it's too small it's quickly.
I think we could actually do this. I don't know why, but I think we could do it.
I think it's ball.
Yeah, Derek, last one.
Ball that's like small and super big, so flashing big and small.
Oh, okay. What do you want to call it?
Be small.
Big flashy, like size flashy.
Size flashy ball. All right. Oh. Before you go. Okay, I do have an assignment for you. You're gonna need to pass it real quick. Pass it real quick. I will tell you, it has 3 questions on it. On the front, it's got a bunch of classes. Pass it quickly. On the front, it has a bunch of classes. On the back, it has 3 questions. Do a superb job on all 3 questions on the assignment. 3. On Monday, we're going to work more with the balls. We're going to make different ball types and all that stuff. Hoop ball, maybe. Who knows? I will take a picture of this. Your assignment is that worksheet. That worksheet, it's got 3 questions on it. Do a good job. Derek logged you off and made sure nobody messed with your computer. Have a good weekend. Make sure you get one of those worksheets. They're coming around. Do I know pie? What is that? Sayonara. Oh, I should know that. That's how you say it. Have a good weekend, everybody. Get one of those sheets. Sayonara. It's not sayonara. How do you say it? Sayonara. Sayonara. Naro. Naruto. Sayun. So, isn't that what the Terminator says at the end of... But he doesn't say it right. Sayonara. Well, sayonara. 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 First try. Steffi, thank you. Whew. I made a video. Oh, I should pause the video.